Okay, Algebra 2 students, this is a video for example 6 for section 2.4. Solve a quadratic equation with complex solutions. How can you solve x squared plus 4 equals 0 using factoring? Well, first we write down the original equation, and we're going to, if it's not already solved for 0, meaning it has 0 on one of the sides, then you need to add or subtract things to set it equal to 0. Rewrite it as the difference of squares, so x squared, and then 4 is a perfect square, so we can break that into 2i squared like we did in the previous problem. And now this factors into x plus 2i times a conjugate x minus 2i. And then we can write, using the zero product property, I can't highlight that, x plus 2i could equal 0, and x minus 2i could equal 0. And then if you solve for x, you subtract 2i from both sides, you can get x could be negative 2i, or in this case, you add 2i, you can get x equals positive 2i. So the two answers for this equation are that x could be negative 2i or positive 2i. Okay? Let's see what they have for us to try. Two problems. I'm going to try to show you a different way, but give these a shot and come on back when you're ready. If it's just x squared plus or minus something, I'm going to subtract 49 to both sides and get x squared equals negative 49. And then I'm going to take the square root of both sides. This is the way I do it, a little bit different than the book. Take the square root of both sides, and it can be positive or negative, whatever I get, right? X equals, now the square root of negative 49, that's like the square root of 49 times the square root of negative 1. And I'll write that out. Square root of 49, which is 7, plus the square root of negative 1, which is I. Don't forget the positive or negative. So the answer to this problem up above here is positive or negative 7i. A little different way of doing it than what they did in the book. I'm going to use a similar strategy here on this one. I'm going to, go ahead and click pause if you want to give it a shot. I'm going to subtract 25. And then I'm going to have 9x squared equals negative 25. And then I'm going to divide both sides by 9. I'm trying to isolate the x squared. When I divide by 9, I get this mess. Okay, x squared equals negative 25 over 9. But then I take the square root of both sides, and that becomes x. And then I have the square root of this mess. Keep in mind, that can be 25 times negative 1. So I just have to take the square root of 25, which is 5, and the square root of 9, which is 3. X equals positive or negative. Probably should show my work. All right, this would be the square root of 25. This is the square root of 9. I also have the square root of negative 1 up here. Okay, so the square root of 25 is 5. The square root of 9 is 3. And I still have this square root of negative 1, which is just I. So here are the answers to this equation. Positive, negative, 5/3 I. Let's see what they had for the two answers. Negative 7i and positive 7i. And then for this one, negative and positive 5 over 3i. Now the I they have on the bottom, you're not supposed to have I in the denominator, so you should write it on the side like I did. This is proper. You shouldn't have I in the denominator. You can write up in the numerator, so this I right here could have been written in the numerator. I do not like how they wrote it in the denominator. Personal preference, I guess. Here's a summary. Summary page where we've learned about complex numbers and operations imaginary unit I is a number whose square is equal to -1, and we use that in this entire section. We have addition, keep the real parts together and the imaginary parts together. The subtraction, keep in mind you need to distribute the negative sign. For multiplication, you do like a double distributing where you're multiplying everything by everything, and I didn't do that very well there. But then don't forget the I squared can become -1. So a lot of things simple up, so you only have a real and imaginary part in the end. And the trick on division was multiplying by the complex conjugate. So for this example, we have 5 minus I, so we would multiply the numerator and the denominator by 5 plus I. And it all got squared away. That's a quick summary of the section. After doing this example 6, your teacher could assign you some of these problems: 40, 41, 42, 43, 44, 45, and 49. That's it for this video. Have a great day.